In this relatively short presentation, we're going to take a look at the theory of cybernetics, which has control and self-regulation via communication with an emphasis on feedback as the primary tenet. We take a look at it because it's an extension of systems theory, and it is also a good metaphor or analogy for the way the human brain works. A great deal of our own communication processes and responses and encoding of messages and so forth are influenced by our control and our own self-regulation. We talk to ourselves, sometimes out loud, but frequently you find yourself in a process of self-talk, thinking through, I did a good job of doing this, or ooh, I made a mistake with that. I need to word this differently the next time. That wasn't a very good approach to use with my boss. I think I'll change my tactic the next time I go in. We'll find later on in interpersonal that we often change also based on who our audience is. But cybernetics involves control and self-regulation by using communication, and feedback is extremely important in this process. Okay, every cybernetic mechanism has goal parameters, whether it's your human mechanism trying to pass the course during a semester, whether it's a rocket ship trying to make it to Mars. There's some goal parameters that have been set. When you enroll in a course at the university, you have a goal for a particular type of grade. Some of you are happy with a C or anything C or higher. Others of you only want A's because that's what you're striving for in order to graduate summa cum laude. So our goal parameters vary depending on the cybernetic mechanism and the goals of that mechanism. But every cybernetic mechanism has a control center, and that control center consists of the sensor, the comparator, and the activator. In the case of humans, of course, that control center is the human brain. And when you get a grade back on an exam, your mental sensory system looks at that grade and it's an 82. For some of you, that's a cause for celebration. For others, that's not a cause for celebration. It doesn't meet the goal parameters that the student has set for himself or herself. So a comparison is made. Mentally, there's a comparison between what actually occurs and what the goal was that was defined in the first place. If that goal is being met, then there's positive feedback, and that says maintain deviation in the same direction. Keep doing what you're doing. Keep going in that direction. If you get a couple of grades back and there was an 82 and then there's a 77 and a 69, that's negative feedback. It's going the wrong direction, and so there's a need after comparison to do activation that involves correction and corrective action capability. So whether it's a rocket ship that's off course or a student off course in grades, the feedback will tell you which way to deviate. And it's a slightly different use of the word feedback from the way we're normally accustomed to it, because we usually just think of feedback as our response to the situation. But when we distinguish between positive and negative feedback says that we need to change the direction that we're going, alter the parameters so the correction takes place. Positive feedback says keep deviating, but do it in the same direction. Keep going the way you're going because you're on a good track. Examples of cybernetic systems include air conditioning or a sophisticated computerized guidance missile system. If you've had your thermostat off, perhaps you've been on a trip or something away from home, and you turn the AC on and you lower the thermostat, that air conditioning kicks in, comes on, and the cool air is blowing, so there is positive feedback which says keep going in the direction that you're going. Eventually you'll reach the ideal temperature and then the system will cut off. Similarly with the guided missile system, as long as the missile or the plane is on the correct trajectory, that's a positive type of feedback. I think you get the idea. I hope so. So cybernetics, while relatively short as a theory, is still an extension of the systems theory approach and has those characteristics that we've just talked about.